in a coherent, sensible way. And so, oh wait, I forgot I have some real life examples. That's my daughter Kayla. And Kayla, at this point, was a sophomore, and Kayla was doing this problem. I gotta tell you, this is such a good story. Anybody want to guess what Kayla did?
Cross multiply.
Cancel the twos.
Cancel the twos.
Yes.
X minus 1 equals n plus n.
Well, that's not the right answer.
She's your daughter, Scott?
Add 1 to both sides.
Is that math, G?
So at some point in her doing her homework, because she cares, she has two older brothers who don't care about anything. And so, well, barely. And so she actually cares, wants to do well, wants to learn. And so she, Dad, come and check my homework. And I saw that, and oh no. Now I have a choice to make. Do I just tell her what to do, or do I take some time and try to help her make sense? Now, if I just tell her what to do, she'll be happy. She'll get her homework done, she'll get the points tomorrow in class, she'll be happy. If I try to help her to make sense, I'll be happy. She won't be. So, I decided that her being happy is not important. And I did a little sense making with her. And here's what we did. I just said, I covered up everything, back to here. I covered up the original problem except for X. I said, Kayla, what is that? And she said, it's an X. But what does it mean? What does it represent? She didn't really know. It's an unknown or something. I don't know what she said. But she didn't really have the idea that that's a variable, that variables vary, and that we're just right now thinking about this almost like a placeholder. This is a value that we don't know right now, but it's a number. X represents a number, doesn't it? And I said this. All right, well, what's that? X minus 2. I know it's X minus 2. What does it mean? Well, she catches on pretty quick. She knew what the right answer would be. She said, it's a number? Yes, it's a number. But here's an even more important thing for her to see. Compared to that number, how big is that number? That number is 2 less than that number, isn't it? Man, I want them to see that. I want my students to understand that these are numbers, and we want to compare. We want to have this quantitative comparison between that number and that number. That number is 2 smaller than that number. All right, now we keep going. I cover everything up, and now I reveal this. Kayla, what's that? It's a number. Wait, she's quick. Yes, it's a number. But in relationship to that number, what can you say about that number? That number is half as big as that number. Ooh, but now I had to stretch her a little bit. You can say that is half as big as that. But you can also say that that is twice as big as that. Or, going back to here, we can say that's 2 less than that, but we can also say that that is 2 more than that. I'm going to see it both ways. All right, here we go. For whatever this stuff is, whatever this number is over here, it happens to be equal to this number over here. And the goal, of course, the exercise was solve for x. So let's solve for x now in a meaningful way. So I wrote down, let's see, I guess I can't really show you how I did it, except I'll cover this up. So I just wrote down x minus 2. And I said, Kayla, what did you tell me about the relationship between this number and this number? Oh, this number is 2 times larger than that number, right? Well, if that number is equal to that number, and that number is 2 times larger than that number, then this number has to be 2 times larger as well. Did you follow that? Now, it's not like, don't think that if you go to class tomorrow and say that to your kids, they're going to go, oh, I get it now. It doesn't work that way. They have to practice thinking about that, And with Kayla, even though I had this one moment getting her homework done, she has to continue practicing thinking that way. But we, kind of work through it. And then now, we're trying to isolate the x. We're trying to figure out what that number is. So I just wrote down the x. Now, if there's just an x here, what's the relationship between that number and that number? That number is 2 bigger than that number. That number is 2 less than that number. That number is 2 bigger than that number. Well, that number is equal to that number, and this number is 2 bigger than that number, then this number has to be 2 bigger as well. And so this whole add 2 to both sides business you guys know, they don't do it right ever. They do like Kayla did. They do it all wrong anyway. So why not start practicing getting them to think more quantitatively, comparing these quantities, and get them to add 2 to both sides in a meaningful way. They're adding 2 to both sides because it makes sense. Because that number is too bigger than that number, so making the number 2 bigger makes sense. So I tried. Well, we continue to try that. But anyway, so this kind of brought me to this realization that for me, here's how teaching and learning ought to happen. You got to start down here. There has to be meaning and purpose. Then, kind of in a problem-solving process. And when I say problem-solving, I don't necessarily mean a word problem. This problem for Caleb was a problem. A problem that she didn't know how to do. Well, she did, but she got it wrong. But it's a problem that she doesn't know how to do, and so we have to figure out how to solve it in a sensible, reasoning kind of a way. So when I say problem solving, I don't necessarily mean word problems. And then in that, we're developing concepts. The concept I was trying to develop with Kayla was quantitative relationships between these algebraic things. And then all of that eventually may lead to a fact and a skill. Kayla may eventually say, can I just add 2 to both sides? Yeah, you can. But why are you adding 2 to both sides? Oh, because this is 2 more than that, and she could reason it through. The fact and skill needs to be kind of the top of the heap. And it's just my opinion, I think that across the country, our math curriculum is more like this. We start with facts and skills. And then we do more facts and skills. And then we do some more facts and skills, and some more facts and skills. And as you were saying, we have to just cram that down their throat because it's all the Ames test. And I think we do it all wrong. I think we need to do this. So we have to really ask these tough questions. What are the meanings that are lacking? When you work with a student, like these elementary teachers, pre-service elementary teachers I'm working with, place value is something they're lacking. So I spent some time just working on their place value. And then you have to ask this question: do we always know the meanings, or are we just good at procedures? I'm telling you, I'll admit, I'll be the first to admit I have a problem. That I was really good at the procedures. That's why I became a math teacher. And only over the years now do I start to look at things and go, oh my gosh, I don't even know the purpose and the meaning. So I gotta go find out. Do we have the time to help students to develop these meanings? You gotta cover all the curriculum. Do you have time? It's a tough one, isn't it? One of my colleagues over at SCC, Ted Coe, he says, I love this. If you don't have time to teach it right the first time, when are you going to have time to teach it the second and third and the fourth time? Isn't that what our curriculum kind of has become? Review and review and review and review. There's so much material to cover. Students are so third. And what if the student doesn't even care, like Kayla? Kayla, I love Kayla. But she didn't really want to do that night. I kind of had to force her. She was a little grumpy about the whole thing. But what if a student doesn't care? Well, I say if the student does not really develop a well-connected network of understanding, if they're not willing to build upon meaning, purpose, making sense, reasoning, thinking, conceptual understanding, if they're not really willing to do that, we're kind of wasting our CO2. Because they're just going to have to retake the class anyway. All right, for all of my colleagues here, what did we just learn this semester? Of the 1,200 and something students that took the placement exam, 80%? 70%? What was it? 80% of them test into math 082. There's something wrong. Now, I don't know, there might be something wrong with the testing, there could be, but I think part of what's wrong is they're not really learning for understanding, making sense.